Boys and girls, this is Mr. Manise here again with another super cool video, and in this video I am going to walk you through how to solve each of the problems on our polynomials test review number 2, which is going to cover binomial expansion, Pascal's triangle, long and synthetic division, finding the zeros and the factors of a polynomial, and graphing polynomials. So my disclaimer as always, I'd like for you guys to work the entire test review and only then come to the video and see if you can figure out where you might have made any mistakes or to clarify any misunderstandings that you might have. So let's go ahead and jump on in. Number 1 says use your knowledge of binomial expansion or Pascal's triangle to expand this binomial 2a minus b to the 6th. I will allow you guys to use your Pascal's triangle sheet, or I might just put Pascal's triangle on the board. Of course, if you want to go the other route and use the combinations method with the 7 choose 2, 7 choose 3 route, you certainly can do that. I'm going to use Pascal's triangle on number 1, and we are in, which row are we in? We are in the 6th row because we're raising it to the 6th power. So if you look at your Pascal's triangle sheet, you will see that the coefficients for each of the terms in this expansion are going to be 1, 6, 15, 20, and then there it just goes backwards, 15, 6, 1. Okay, so that means that when I expand these terms, I will stick this coefficient in front of all that, and I will be multiplying these numbers by each of these terms. Okay, so to refresh your memory, what we're going to do is we're going to take the first term and we're going to raise it to that power, and then every subsequent term as we go down the list there, or down the expansion, this number will decrease, and it'll be 2a to the 5th and then 2a to the 4th. Conversely, for the other term that we're going to multiply by, we're going to take this term and we're going to go backwards. We're going to start off raising this term to the 0 power, and then eventually we're going to count up and get to the 6th power, or to that power. Okay, so here is how it's going to work. The first term is going to have that coefficient of 1. Okay, so I'm going to have 1, and then I'm going to have this first term, okay, which is going to be 2a. All right, I'm going to raise that to whatever power is outside. I'm going to raise that to the 6th power. And then I'm going to have the second term, which is negative b, and I'm going to raise that to the 0 power. Okay, now if this inside term, guys, if this inside term is positive, then that's pretty nice, because that means all of my terms are going to be added together. Okay, plus signs everywhere. However, if this inside term is negative, like in this case, that means that my signs are going to alternate back and forth between positive and negative. This first term in any expansion is always going to be positive, because if that second term is positive or negative, we're raising it to a 0 power, and anything to the 0 power is 1. Okay, so you're always going to take this first term and you're going to raise it to that power, and you should get a positive overall value. Okay, then after that, so I'm already thinking to myself, my terms are going to be positive, negative, positive, negative, positive, negative. Okay, so this first term is going to be positive, so I know my next term is going to be negative. Okay, all right, so the next term is going to be minus. Okay, and then we take the first term. Actually, we take the coefficient here, our next coefficient, Pascal's triangle, so it's going to be 6, okay, times the 2a. But now this time I'm not raising it to the 6th power, I'm decreasing, so I'm raising that to the 5th power. Okay, and then I'm going to take the second term, the negative b, and I'm going to raise that to the 1st power. Okay, so these numbers are decreasing left to right, these numbers are increasing from left to right. Okay, so you might look at that and you might say, okay, well this is negative b, so isn't a negative times a negative positive? And it's kind of up to you how you want to do this. If I know that my signs are alternating plus, minus, plus, minus, plus, minus, then I don't really care about that sign anymore, because I've already taken that into account. Negative b to the 1 is negative, that's why this second term is negative. Okay, so if you want to keep it as the negative and then figure out what the signs are in each case, have at it. I'm just going to go positive, negative, positive, negative, positive, negative. All right, so my next term is going to be the next term in Pascal's triangle. The next term is going to be positive, so plus 15, and then we're going to take the 2a and raise that to the what? 6, 5, 4. We're going to raise that to the 4th power after we get my webcam to work with us. Here we go. And then I'm going to take the second term, negative b, and I'm going to raise that to the what? 0, 1, 2. Raise that to the 2. Because negative b squared is a positive, that's why this term is positive. All right, the next one's going to be 20, and I already know that it's going to be negative, so just go ahead and write down a negative. All right, 20 times 2a, I'm going to raise that to the third, that's decreasing by 1, and I'm going to raise the b to the 0, 1, 2, 3. Okay, and then the next term is going to be positive, and just keep going. 15, 2a to the second, negative b to the fourth. Okay, keep going, got 2 more. And then we got plus 6 times 2a to the first, negative b to the fifth. And actually, let me check this. Negative, positive, negative, positive. This one should be negative. Let's call myself there. So that one should be a negative. Alright, so that term is negative. And then the last term is I have another 1. So this term is going to be positive, and then it's going to be 2a raised to the 0, and then the negative b raised to the 6th. Okay, so that's a lot of stuff there, guys. So I would just take a minute and just go back and check. 6, 5, 4, 3, 2, 1, 0. That's good. 0, 1, 2, 3, 4, 5, 6. That's good. Okay. Now it's a matter of going ahead and cleaning this up and multiplying all this out. So the negative b to the 0, that's just 1. And then I've got 2a raised to the 6. So I have to do everything in parentheses raised to the 6th power. 2 to the 6th power is 64. Times 1, of course, is 64. So this is going to give me 64. I also have to raise the a to the 6th power, 64, a to the 6th. My next term is going to be negative. Now here, I've got 2 to the 5th. Okay, so let's do that. Can't do that in your head. Let's use your calculator here. So I've got 2 raised to the 5th, but then I'm multiplying this number times the 6 out front. So times 6, that gives me 192. Okay, so I already know that my term is going to be negative 192. Now I can't forget about the variables. Now I have a to the 5th, and then I have this b to the 1, or just b. Okay, again, don't worry about the negative b's in here. Okay, I don't really care about these negative b's anymore, since I already know what the signs of all my terms are going to be. So I just kind of ignore that. All right, so now let's go to the next term. Okay, so we've got 2a to the 4th, so we got to do 2 to the 4th. Hopefully you guys know that off the top of your head. That's 16. But then I have to multiply that times the Pascal's Triangle coefficient. Remember, Pascal's Triangle are just telling us what are the coefficients in front of each of these expanded terms. So I have to do that times 15, and that gives me 240. Okay, we got positive, negative, positive, 240, a to the 4th, and then I have this b squared. Okay, let's keep going. I have 2a to the 3rd, so 2 to the 3rd is 8, and 8 times 20 is 160. So we got positive, negative, positive. This is going to be negative. So 8 times 20 is 160, so negative 160. A to the 3rd, b to the 3rd. Okay. And then I have 2 squared, that's just 4. 4 times 15, this negative, this is going to be positive, so plus 60. All right, and we got a squared, and then we have this b to the 4th. All right, and my next term is going to be negative, and now I just have 2 to the 1, which is 2. 2 times 6 is 12, so minus 12. And then I got a to the 1, and now I have a b to the 5. Okay, and then I got the last term. 2a to the 0, that's just 1, that goes away, and I just have b to the 6th. Okay, let's check. Positive, negative, positive, negative, positive, negative, positive. Okay, we're good to go. All right. Now, I'm not going to, for the sake of this video, so it doesn't get too long, I'm not going to go through actually checking this, but you guys know that I've taught you to check this before. You would type this into your calculator. I'm not going to do the whole thing, but you would type in parentheses 2 alpha A, 2 alpha A minus alpha B. and I'm going to raise that to the 6th power. That's going to give me some number. Fine, whatever, 64, okay? And now I'm going to take all of this and plug that into my calculator and make sure it equals 64. You know what? Let's just go ahead and do it. 64 alpha A raised to the 6th minus 192 alpha A. Oops, start the exponent. 64 alpha A raised to the 6th, bring my cursor down, minus 192 alpha A raised to the 5th, alpha B. This is one of the longer ones to check, of course, plus 240 alpha A raised to the 4th, B squared, minus 160 alpha A raised to the 3rd, drop my cursor, alpha B raised to the 3rd, drop my cursor, plus 60 alpha A squared, alpha B raised to the 4th, minus 12 alpha A, alpha B raised to the 5th, drop my cursor, plus alpha B raised to the 6th. Drum roll. Oh my gosh. They match. 64 equals 64. Okay, yeah, that took me maybe 30 or 45 seconds to check that. That's one of the longer ones of using the little trick I've taught you guys. But guys, don't ever turn in your quiz and test until you check every single one of these that you can check. And that's what I love about math. You can't do that in other subjects. You can't guarantee that you got the right answer. This will allow you to check, wait a minute, they don't match. Oh, this is supposed to be positive. Oh, wait, that's supposed to be a b to the 3rd or whatever. That allows you to go back and check your answers. Okay, number 2, what is the 3rd term in x plus 3 raised to the 7th? Okay, so here they're not asking us to expand this whole thing. I just want the 3rd term. So here, now in this case, you could actually use Pascal's triangle because we're only raising it to the 7th power, and you have 7 rows in your Pascal's triangle. But if this were raised to the 26th power, then I'm going to be forced to use the combinations method that we learned. Okay, I'll go ahead and use the combinations method even though you could use both, just in case you guys see something higher than this on the test. Okay, so the first thing I'm going to do is I don't have the Pascal's triangle coefficient, so I'm going to have to use the combination method. All right, so what I'm going to do is the first term, it's going to be very similar, but instead of the first term being some number, we're going to have to do this value. Okay, so I'm raising it to the 7th power, so it's going to be 7 choose 0. Okay, it's always going to start with 0. All right, how do I do that on my calculator? So to refresh your memory, you're going to type in, depending on which calculator you have, it might look a little different. For I got an older version, so yours is going to look a little different than mine. I'm going to type in 7, and then I'm going to go math, and then I'm going to scroll over to probability, and I go down to option number 3. There's my N choose R. N things choosing R number of ways. Okay, so I'm going to press that button, and then I'm going to type in 0. 7 choose 0 is 1. Okay, so it's saying I've got 7 things and I'm choosing 0 things. How many different ways can that happen? That can only happen one time. All right, so 7 choose 0 is 1. Guess what? If you looked at your Pascal's triangle, of course that first term is also going to be 1. So this is just another way of getting the same coefficients in Pascal's triangle. And now I'm going to do the same thing as we did up here. It's just still going to be that guy raised to that power. Okay, so times x raised to the 7th, and then it's going to be the second term, all right, and then it's going to be raised to the 0. So it's going to be 3 raised to the 0. Okay, that's the first term. This inside term is positive, so that means all my terms are positive. That's kind of nice, so I don't have to worry about that. My second term, instead of 7 choose 0, is going to be what? 7 choose 1. And then it's going to be times x raised to not the 7, but it's going to be raised to the 6th. Okay, and then this term is not going to be raised to the 0, it's going to be raised to the 1. All right, this is my first term, this is my second term. I want the third term. Okay, so all I care about is this next guy. This is going to be 7 choose 2. Okay, 0, 1, 2. And now it's going to be the x raised to the 7, 6, 5. And then the 3 is going to be raised to the 0, 1, 2. Okay, this is the third term. Okay, this is all I care about. How do I simplify this third term? Okay, so on my calculator, I need to do 7 math probability 7 choose 2. Okay, so that gives me that number. All right, so that's going to be equal to 21. And then now I've got to raise 3 to the second power, which is 9. So 21 times 9 is going to give me that number. So 21 times 9. Now I still have this x to the 5th. And 21 times 9, so this is going to give me 189 x to the 5th power. That is the third term in this expansion. So notice we didn't have to expand the whole thing, we're just stopping on that term. Okay, so 189 x to the 5th. Unfortunately on this one, there's really no way to check this, okay, because we're not expanding the whole thing. All right, other than just to go back and make sure you're checking your numbers. And I always, just me personally, Mr. Manise, I always like to go back and do those quick little gut checks. 7, 6, 5, 0, 1, 2, because at some point everybody's going to go 7, 6, 4, okay, or 7, 6, 6. I mean, nobody's immune to that. So you always can go back and do those quick little gut checks. Okay, number 3 and 4, they're asking us to divide using the appropriate method. That insinuates that there's more than one methods, which there are. We learn how to divide polynomials by long division or synthetic division. I would like to use synthetic division if I have the choice, but I can only use synthetic division when this coefficient is a 1 and when the exponent is a 1. I only have one of those. I only satisfy one of those. Okay, so I can't use synthetic division here because that's not a 1. So I'm forced to use long division. That's fine. We spent a week on this. Okay, so I'm going to divide this. This is my divisor, dividing it into this polynomial. So write kind of small if you haven't. There's a lot of stuff here. Okay, 4x cubed minus 8x squared minus 13x plus 20. A lot of students ask, Mr. Manise, do I need a 0 as a placeholder in here, say if I didn't have this x term? Technically, no, but I would if I were you, because I taught you guys to line these things up vertically, especially for synthetic division. So yes, I would personally leave a gap there, just so I'm lining things up. All right, now when I do long division, guys, all I care about is the front terms of both my dividend and my divisor. Divisor, dividend. How many times does 2x go into 4x cubed? So you're asking yourself, 4x cubed divided by 2x is equal to what? Okay, all right, 4 over 2 is 2, x to the third over x is x squared. Okay, so this is going to be 2x squared. I'm going to put that above the x squared column, just so I'm kind of lining things up vertically. All right, now once I do that, I've got to go back and multiply this guy by both of these terms here, by both of the terms in the divisor. 2x squared times 2x is 4x to the third. But remember, the way I taught you guys is whenever you go back and multiply these guys, you're going to be subtracting it. So I just taught you just whatever you get here, just flip the sign. 2x squared times 2x is 4x to the third, but I flip the sign, so it's minus 4x to the third. All right, 2x squared times negative 5 is negative 10x squared, but I flip the sign, so plus 10x squared. Okay, now notice these guys have to cancel. Okay, those front two terms, they have to cancel and go away. Negative 8x squared plus 10x squared, that gives me a 2x squared. And then I can bring down the rest of the stuff. And now I'll do it all over again. How many times does 2x go into 2x squared? So in other words, 2x squared divided by 2x is equal to what? Okay, 2's cancel, x squared over x is just x. Okay, so I'm going to put a plus x up here in the x column. I've got to multiply x times 2x, that's 2x squared, flip the sign, minus 2x squared, as we expected. X times negative 5 is negative 5x, flip the sign, plus 5x. Those front two terms cancel. 13x plus 5x is 8x, and then I bring down the 20. Okay, how many times does 2x go into 8x? 8x divided by 2x is just 4. Okay. Oh, I'm sorry. I'm sorry. I caught myself. Negative 13x plus 5x. That's a negative 8x. Sorry about that. So it's negative 8x over 2x. That should be a negative 4. Okay. Okay. Negative 4 times 2x is negative 8x. But flip the sign. That's a positive 8x. And then negative 4 times negative 5 is a positive 20. Flip the sign. That's a negative 20. And we actually get a remainder of 0. Okay, but notice what they're asking for, guys. They're not asking for you to evaluate or what is the answer. They only want the quotient. This guy up here that I put a box around, that is my quotient. Okay, so when they ask for the quotient, they don't care about the remainder. In this case, it doesn't matter because my remainder is 0. But let's say this gave us a remainder of 5. The quotient would still be that guy, 2x squared plus x minus 4. Okay, that is my quotient. Now, how can I check this? We can just type it in. I'm not going to check every single one of these. I don't want this to be a 2-hour video, but I do want you guys to be able to check these things. All right, so let's do 4x raised to the third, drop my cursor, minus 8x squared minus 13x plus 20. Okay, now, actually, I should have put that in parentheses, but so insert parentheses. Okay, divided by parentheses 2x minus 5. Okay, we get some number. Okay, fine. Don't care what that number is. Okay, we're saying that that's equivalent to 2x squared plus x minus 4. Oops. Let's see that. 2x squared plus x minus 4. What in a? They match. Now, again, if this had been a remainder, okay, if this had been a remainder, then we would need to, if I'm checking this with my calculator, I actually would need to add on this remainder to make sure that this divided by this gives me the quotient plus the remainder, okay? In this case, it doesn't matter because the remainder is 0. All right, the next one, what appropriate method do you want to use? Okay, I want to use synthetic division because the coefficients are 1 and the power, the exponent is 1. Now remember, when you do synthetic division, you got to flip this sign. Okay, so I'm going to use a positive 4. And always remember to ask yourself, do I need any placeholders? Don't forget the placeholders. Okay, I've got a 3, I've got a 2. Whoops, I'm missing the x term, so I got to put a 0 there. So a 1 for the coefficient there, a negative 6. I've got a 0 because we're missing the x term, and then a 32. Okay, synthetic division, I'm going to bring down my 1. 4 times 1 is 4. Negative 6 plus 4 is negative 2. 4 times negative 2 is negative 8. 0 plus negative 8 is negative 8. 4 times negative 8 is negative 32. And we do, in fact, get a remainder of 0. Okay, so what I'm left over with is going to be the quotient. All right, there, negative 8 is my constant, negative 2 is my x, and there's my x squared, so that's x squared minus 2x minus 8. And that is my quotient. Okay, once again, if this had been, say that had been a remainder of 3, this would still be my quotient. Okay, just want to make sure you guys are okay with that. Okay, so let's move on here. Number 5, given, that's nice. They tell us one of the factors, okay? So x minus 1 is a factor. Find the real or imaginary complex roots of this following polynomial. Okay, so here is where our, if they don't give us a factor, we would need our rational roots theorem, but in this case they give us the factor, okay? So they're basically telling us that 1 is one of our zeros, 1 is one of our x-intercepts. All right, so I can use synthetic division using this factor. So if I flip that, that's going to be a 1. Do I need any placeholders? 3, 2, 1, 0? Nope. So 3, 5, negative 11, 3. Bring down the 3. 1 times 3 is 3. 5 plus 3 is 8. 1 times 8 is 8. Negative 11 plus 8 is negative 3. 1 times negative 3 is negative 3. And we get a remainder of 0. Does that make sense? Were we supposed to get a remainder of 0? Absolutely. If they tell me that is a factor, that means that when I do synthetic division, I will get a remainder of 0. Otherwise, it wouldn't be a factor. But now they're asking us to find all of the possible roots in the zeros. Well, there's one of them. Okay, so one of my zeros I know is going to be a 1. Now I've got a quadratic. I've knocked this cubic down to a quadratic that I can now solve. So this is going to be 3x squared plus 8x minus 3 equals 0. Can I factor that? Well, let's try the rainbow thing. Let's factor when a is not 1. 3 times negative 3 is negative 9. Are there any factors of negative 9 that add to 8? The answer is yes. A positive 9 and a negative 1 adds to 8. So I'm going to split this middle term. And we're going to go, I will put the 9 with the 3. That makes sense. I'll put the negative x with the negative 3. And now I can draw my curtain. And I can group. I can pull out a 3x. That will leave me with x plus 3. When that front term, when you do the curtain, the grouping method, when that front term is negative, you must pull out a negative. So I'm pulling out a negative 1. That is also going to leave me with x plus 3. Okay, my two binomials in the parentheses match, so that's good. Bring this up here. So my two factors are going to be x plus 3, the matching parentheses, and then the stuff left over on the outside, which is going to be 3x minus 1. Okay, I'm going to set that equal to 0. That one I can just flip the sign. I get a negative 3. That one I've got to move the 1 to the other side. You've got to solve this little mini equation. Hopefully you guys are proficient at doing this in your head. 3x equals 1 divided by 3. And my other 0 is going to be 1/3. Okay, but I have a cubic. Where are my 3 zeros? There are 2 of them. Those 2 come from the quadratic, but I have this original 1 because that's a factor. So my other 0 is a 1. Okay, now when they're asking for the factors, don't miss this. Don't miss points tomorrow because of this. If you guys remember our notes from writing equations, do you guys remember when I said, okay, if I've got a 0 of 1, 2, and negative 4, how would we write that as a factor? We'd flip the signs. It'd be x minus 1, x minus 2, and x plus 4. All right, the way we learned it is when I write it in factor form, it's always going to be x minus my root times x minus my root, etc., etc. Okay, so a lot of you guys are going to be tempted to throw this 3x minus 1 down there, but it really needs to be x minus root, or x minus my 0. These are my 3 zeros, so I need to go from here and flip these signs. So my factors are going to be, flip that sign, x plus 3, flip that sign, x minus 1/3, flip that sign, times x minus 1. And that makes sense because they told us x minus 1 is a factor. Okay. Now the zeros are going to be, the roots are going to be those guys. So negative 3, 1/3, and 1. Okay. I'm not going to ask you to do this on the test, but it's good to know what we've used to be able to solve this problem. We used synthetic division. And what else did we do? I would say and factor by grouping. Okay. All right, number 6. Use the remainder theorem to find the remainder for this polynomial, this quartic divided by x minus 2. Okay, now this one I believe is one of the multiple choice problems tomorrow on the test. I don't know, I'm not going to be able to tell whether or not you use the remainder theorem or you can use synthetic division. Okay, we remember our little choice board activity, it doesn't really matter. Okay, you could either go ahead and do synthetic division and verify what the remainder is, or technically to use the remainder theorem, I'm going to flip that sign and then I'm going to take x equals 2 and I'm literally going to plug it in everywhere you see an x. I'm going to plug in a 2. Okay. So this is going to be 3 times.
Zach Osborne, if you're still in the building, your ride is in the front of the building. Zach Osborne, your ride is waiting for you in the front of the building.
Okay, so sorry about that. So 3 times 2 to the 4th minus 5 times 2 to the 3rd. What do we got? Plus 2 times 2 squared minus 12 times 2. And then plus 11. Okay, so our remainder theorem says if I take my factor, flip the sign and stick it in, whatever I get will be my remainder. Okay, so if I do that on my calculator, okay, 3, 2 to the 4th minus 5, 2 to the 3rd plus 2 times 2 squared minus 12 times 2 plus 11, I get 3. Okay, so our remainder, I would say my remainder is equal to 3. Okay, ironically, guys, for those of you who sometimes make mistakes in synthetic division, you probably want to do this. Honestly, guys, I could probably do synthetic division even faster than this. Okay, so 4, 3, 2, 1, 0. I don't need any placeholders. I'm going to flip the sign. 2, I got 3, negative 5. 2, negative 12, 11, 3, 6, 1, 2, 4, 8, negative 4, negative 8, 3. Bam, there you go. Okay, so my remainder is 3. How'd you do that so fast, Mr. Manise? Because I'm a wizard? Okay. So anyway, I don't really care which way you guys use it tomorrow. I'll do it tomorrow, but anyway, a couple of different ways to get your remainder. Okay, so number 7, determine whether x plus 8 is a factor. Okay, so we just said if it is a factor, you will get a remainder of 0. Okay, just like we did up here. 1 was a factor, we got a remainder of 0. Okay, so how do you want to do this? Okay, so again, you could either use the remainder theorem or you could use synthetic division. I'm going to use synthetic division on this, but you got to remember to flip this sign because x plus 8 is a factor, but the 0, the x-intercept is actually going to be negative 8. Okay, that's why we have to flip the sign. So I'm going to do synthetic division. Do I need 4, 3, 2? Oop, I'm missing the x term right there, so you can't forget that 0. 2, 16, 3, 0, negative 184. Okay, I'll do this a little bit slower. Bring down the 2. Negative 8 times 2 is negative 16. 16, negative 16 is 0. Negative 8 times 0 is 0. 3 plus 0 is 3. Negative 8 times 3 is negative 24. Plus 0 is negative 24. Negative 8 times negative 24, guess what? That's 192. And if I add those, I'm going to get 8. So we do not get a remainder of 0. So my answer would be no, x plus 8 is not a factor because Mr. Manise says no. Because the remainder is not 0. Okay, let's keep it going. Flipping on over to the back. Use synthetic division to evaluate the function. Okay, evaluate. They're not asking for the quotient. They actually want us to figure out what is the answer that I get when I divide this cubic by this binomial, by this binomial. Okay, so how do you want to do this? Okay, synthetic division. I can use synthetic division because they say use synthetic division, but also because the coefficients are 1 and the exponent's 1. Flip that sign, so I'm going to have 4. Do I need a placeholder? 3, 2, 1, 0. Nope. 2, negative 11, 6, negative 5. Okay, so bring down the 2. 4 times 2 is 8. That's going to give me negative 3. 4 times negative 3 is negative 12. That is going to give me negative 6. 4 times negative 6 is negative 24. Negative 5 minus 24 gives me negative 29. Okay, now here's where we are going to need the remainder. Okay, so you guys gotta dig deep. It's been a few weeks since we've done this. So this is my quotient, and this is my remainder. So I've taken my cubic and I've knocked it down to a quadratic. So my quadratic is going to be 2x squared minus 3x minus 6. But how do I write this remainder? Okay, the remainder is going to be this value divided by what? Divided by the divisor. So it's going to be over x minus 4. Okay, that's going to be my answer. Okay. Now, if you're typing that in your calculator to check, this is the way you would type it in. Okay, so we got 2x squared minus 3x minus 6. I don't need to put the numerator in parentheses because it's only one thing. Now, if there were two things up here, like a negative 29x plus 2, I would need to put that whole numerator in parentheses. But in this case, I literally can just type minus 29 divided by, now the denominator I must put in parentheses because I have more than one term down there. So parentheses x minus 4, close the parentheses. Your calculator will see this order of operations is it's going to do the division first. Okay, so 29 divided by that. All right. Okay, so if I type that in, I get some number. Fine, whatever. Okay. All right, we're saying that that answer is the same exact thing as 2x raised to the third minus 11. Oh, I need parentheses here, sorry. Parentheses 2x raised to the third minus 11x squared plus 6x minus 5 parentheses divided by parentheses x minus 4. Ta-da, they match. So that lets me know I've got the correct answer. Number 9. Okay, flip that sign again. So we're using another 4, 3, 2. Oh, I'm missing the x term. Okay, so 2, negative 7, 0, negative 12. Bring down the 2. 2 times 4 is 8. That's 1. That's 4. That's 4. That's 16. And a remainder of 4. Okay. If I'm going too fast through that, guys, I want you to change the speed of the YouTube video. I want you to go up there and slow it down to 25%. Bring down the 2. 4 times 2 is... Okay. All right, so there's my quadratic. So I've got 2x squared plus x plus 4, and then plus the remainder over what? Over the divisor, x minus 4. Y'all can check that on your own. Okay, so let's check out the next one, number 10, determine all possible rational roots. Okay, so this is our rational roots theorem. So to do that, we are simply going to look at the factors of that guy divided by the factors of that guy. Okay, those are my P's and Q's. I'm not a big fan of the P's and Q's, but all right, so it's going to be plus or minus. The factors of 10 are 1, 2, 5, and 10, right? And that's going to be over plus or minus the factors of 2, which are just 1 and 2. Okay, so my possible rational roots are going to be plus and minus. You can just write plus or minus once for all of okay, I'll separate it. Doesn't matter. 1 over 1, plus or minus 1 over 2, plus or minus 2 over 1, plus or minus 2 over 2 is 1. I don't need to write that again. I already have the 1. And I got plus or minus 5, and then plus or minus 5 halves, plus or minus 5 halves, and then I have plus or minus 10, and then the last one I have 10 over 2, which is plus or minus 5, but I already have that. Okay, so those are my possible rational roots. You could just write a plus or minus out in front of all these, and that would be fine for me. Okay, so how do I find my roots and my zeros? Okay, you can start testing each of these numbers and using the synthetic division until you get a remainder of 0. Have at it. Good luck. I'll see you next week. Or you can use what I taught you, which is to plug this polynomial into your graphic calculator and see where it looks like it crosses the x-axis. Those will give us some starting spots that we can test for synthetic division. So let's do that. Okay, 2x raised to the 4th. Drop the cursor, minus 9x raised to the 3rd, plus 8x squared, plus 9x, minus 10. Okay, let's make sure that's typed in correctly. I always like to go back and just check, make sure I didn't type something in wrong so I don't waste a whole bunch of time. Okay, let's graph that. Okay, my graphing calculator is zoomed in, so yours obviously is going to look a lot different. I'm going to zoom out, zoom 6, get back to my standard window. And we get something that looks like that. Okay, does that make sense? It's a W, right? It's x to the 4th. So if it's even, my polynomial is even, then it's either going to be an M or a W shape. And so I got a W. So that makes sense. There's no negative out in front, so there's no reflection. So there's my regular W. That looks good. All right, so it looks like it crosses at -1, maybe 1, maybe 2. I don't know. It definitely looks like it crosses at -1 and 1. So let's start there. Let's test. Okay, that is one of my possible rational roots. So let's test 1. Or excuse me, let's test -1. Okay, 4, 3, 2, 1, 0. I don't need any placeholders. So 2, -9, 8, 9, and -10. 2, -2, -11, 11, 19, -19, -10, +10, and we get a remainder of 0. Okay, so that's good. All right, but now we've taken our quartic and knocked it down to a cubic. I'm not ready to solve anything because I still have a cubic, all right? Now, you could look and see if you could factor this by grouping, but you could see just looking at this, 2x squared minus 11x, 19 and 10, negative 10, that's just not going to happen. So we need to use synthetic division again. So I'm going to go back to my calculator and let's test 1. 1. Now, what do I use synthetic division on? Do I use it on my original or my new one? Okay, I always do synthetic division on the new one, because if I take this and do synthetic division on that, then that's going to give me a cubic. Okay, I don't want that. I want to knock it down from a quartic down to a cubic down to a quadratic. Okay, so I'm going to use synthetic division on that guy. So 2, negative 11, 19, negative 10. Okay, bring down the 2. 1 times 2 is 2. That's going to be negative 9. 1 times negative 9, negative 9. That's going to give me 10. 1 times 10 is 10. And voila. There's another remainder of 0. Now I've knocked it down to a quadratic. 2x squared minus 9x plus 10 equals 0. Can I factor that? When a is not 1, do the rainbow thing. 2 times 10 is 20. Are there any factors of 20 that add to negative 9? The answer is yes, negative 4 and negative 5. So I'm going to break this down into a negative 4x and a negative 5x plus 10 equals 0. And I can draw my curtain. I can pull out a 2x. That'll leave me with x minus 2. That front term is negative, so I've got to pull out a negative. I'll pull out a negative 5. That's going to also leave me with x minus 2. Okay, that's good news. So one of my factors is the x minus 2. My other factor is the leftover stuff, 2x minus 5. Okay, equals 0. Let's flip that sign. So I'll get a 2. If I move the 5 to the other side and divide by 2, that will give me 5 halves. All right, so what are my zeros? Okay, I've got a 2, I've got a 5 halves, I've got a negative 1, and a 1. Those are my 4 zeros. Okay, so we've got 2, 5 halves, negative 1, and positive 1. Okay, so let's go back. I always like to go back and check. Does this make sense? Okay, there's my negative 1 and my 1. Does that spot look like a 5 halves? Does that look like 2.5? Yep. And this spot right here definitely looks like a 2. Okay. If I wanted to zoom in on that, I could certainly zoom in. I could do zoom box. Actually, I'll just do this to make my box go up. Okay. So this spot here, there's my 2. This spot here, there's my 5 halves, basically 2.5. 2.5 right there. So anyway, you can always use your graphing calculator to check stuff. All right, number 11, coming down the home stretch. We're getting close, guys. Identify the zeros of this polynomial. State the multiplicity of each root. So that insinuates that we're going to have a root that shows up more than once. Okay. The first thing you want to do is see, can I factor this, or do I have to go the synthetic division route? Okay, well, is there anything I can pull out? No, there's no GCF. No, I can't factor this. So I'm going to have to use synthetic division. So let's go to, plug this in, x raised to the 4th, 6x squared plus 8x minus 3. I'm missing several placeholders on this one. I'm zoomed in, so I need to zoom out, or zoom standard. Zoom 6. And let's see where it looks like it crosses. That looks like a negative 3, and that looks like maybe a 1. Possibly shake and bake through 1. Maybe. So let's start with the negative 3. Let's test that. Okay, so let's test. I think on the answer key online, I tested the 1 first. But I'll show you that it doesn't matter. We'll test the negative 3 first. Okay, where are my zeros? I got a 4, All right, I got a 1 for the 4. I'm missing the cube term. I got a -6 for the squared term. I'm missing, oh, okay, that's it. That's all we're missing. 4, 3, 2, 1. Okay, I thought we were missing a couple things. All right, and then I got the 8 for the x term, and then the -3 for the constant. Okay, let's bring down the 1. -3 times 1 is -3. 0 plus -3 is -3. -3 times -3 is 9. 9 minus 6 is 3. That's going to be -9. That's going to be -1. -3 times -1 is 3. And indeed, we get a remainder of 0. So I've knocked my quartic down to a cubic. And now I'm going to use the other 0 that looked like it crossed the x-axis at, which was 1. Okay, so I'm going to use synthetic division on that guy. Okay, so we got, actually, I didn't draw that box very well, did I? I give myself a lot of room. Let's draw that box a little bit higher. Okay. So we got the 1, -3, 3, -1. Okay. Bring down the 1. 1 times 1 is 1. -3 plus 1 is -2. 1 times -2 is -2. 3 minus 2 is 1. 1 times 1 is 1. And we indeed get a remainder of 0. All right, so now I've got my quadratic. X squared minus 2x plus 1. X squared minus 2x plus 1 equals 0. Are there any factors of 1 that add to -2? Yes, Mr. Manice, there are. That's -1 and -1. So x minus 1 times x minus 1 equals 0. Flip the sign and I get x is equal to 1. Okay, but I got 2 of them. Okay, so when we come over here and make our chart here for zeros and multiplicity, okay, I got the -3. That shows up once. The graph goes straight through -3, so that's a multiplicity of 1. And the graph does a little shake and bake. Remember, if it bounces, that's a multiplicity of 2. Shake and bake is a multiplicity of 3. Well, where are the 3 ones? There's one of them, and then there's 1, 2 of the other ones. Okay, so I've got a multiplicity of 3. Okay. All right, and you can always test, if you add up the multiplicities, that should always equal the number of the highest order of the polynomial. So it's 4th degree, so I should have a multiplicity of 4 when I add these up. Okay, number 12 says solve the polynomial by factoring. Okay, you could still use synthetic division and you'll get the same answer. However, a lot of times it's going to be easier if we look to see if we can factor it first. That'll save us some time. So what do you notice about all 3 of these terms? They all have x's in them. They actually all have x squareds. So I can pull out a what? GCF. Let's pull out it. And they're also all divisible by what? 2. So I can actually pull out a GCF of 2x. Okay, that's going to leave me with x squared. -6x cubed over 2x squared. That's going to leave me with -3x. And then -108 x squared divided by 2x squared. The x squares cancel. -108 divided by 2 gives me -54. Okay. All right, so I pulled out an x squared. Okay, so we'll just kind of ignore that for the time being. We need to factor this quadratic. What are the factors of -54 that add to -3? That's -9 and a +6. So this factors as x minus 9 times x plus 6. Now remember, guys, I still have sophomores and juniors that still don't understand the difference between when do I have to draw the curtain, when do I factor when a is not 1, and when can I factor when a is 1. When that coefficient is a 1, the a value, a, b, c, that a value is 1. You don't have to split the middle term. You don't have to do any curtain. You're just asking what are the factors of c that add to b. Okay, when I think of 54, the first 2 numbers that pop into my head are 9 and 6. If they multiply to be negative, one's got to be negative, one's got to be positive. The sign of the middle term, the sign of the b term, determines the sign of the bigger one. Since the b term is negative, the bigger one's negative. Okay, there's no need for curtain here. All right, so I really want you guys to nail that down. And then I've still got this 2x squared out front. Okay, all right, so now for that one, I just flip the sign. X equals 9. For that one, I just flip the sign. X equals -6. And if I set this equal to 0, I will get 0. However, this is a quartic. So shouldn't I have four roots? Why, yes, you should. The 0 shows up twice. Okay, so the 0 has a multiplicity of 2. All right, so if I were to do my chart over here, zeros and multiplicity. All right, the 9 shows up once. The -6 shows up once. But the 0 shows up twice. Okay. Now, why is if I just set this equal to 0, I'll get x is 0. So why, Mr. Manise, does a 0 have a multiplicity of 2? Well, if you don't believe me, what I want you to do is I want you to click on that X in the top right-hand corner of your screen. Click on the X and exit out of this video. Just kidding. Just kidding. If you don't believe me, graph it. Let's graph it. 2x raised to the 4th minus 6x raised to the 3rd minus 108x squared. Okay, let's graph that. Now this one's going to be kind of hard to see. It's even, so it's a W. Well, there's your W. Hard to see. I want to zoom in on this little spot at 0 and see what's happening. So again, I'm going to do the zoom box that I taught you guys. Press 0. Let's move my cursor a little bit to the bottom left. Press enter. Let's move the arrow over. Let's create the box, and then I'm going to go up. Let's create the box. If it's a multiplicity of 2, guys, what's supposed to happen right there? It's supposed to bounce. Okay, it bounces at 0. It's got a multiplicity of 2. Because normally when we pull out an x, if I just pull out an x times x plus 3, then I would say my zeros are x and -3. But I pulled out 2 of them. I have an x squared. So that's why the 0 is a multiplicity of 2. Okay, so let's keep going with number 13, home stretch. Graph the polynomial and answer all this stuff. Okay, so the first thing I want to do is I want to find the zeros. Can I factor this? No, there's no GCF. There are 5 terms. Can't do grouping. I can only do grouping with 4 terms. So I'm going to have to use the calculator method to get some starting points. So let's graph this. X raised to the 4th minus 4x raised to the 3rd minus 11x squared plus 66x minus 72. Okay, I'm going to type that in right. Yes, I did. Let's graph that. I need to get back to my standard window. Zoom 6. And let's see where it looks like it crosses. Okay, that looks like a 1, 2, 3, 4. That looks like -4. That looks like 2. Maybe a 3 right there. Okay, so let's start with -4. Okay, so let's test. Again, I think on the answer key I started with 2. So let me be consistent this time with my answer key online. So I'll test 2. Okay, so do I need any placeholders? 4, 3, 2, 1. Nope, I'm good. 1, -4, -11, 66, -72. Hopefully you guys are getting proficient at this by now. 1, 2, -2, -4, -15, 30, -30. 66 minus 30 gives me 36, and 2 times 36 gives me a positive 72. So indeed, we do get a remainder of 0. So I'm taking my quartic, I've knocked it down to a cubic. Okay, now let's test one of the other ones. Looked like it crossed there at 3. So let's test 3. Again, I'm doing synthetic division on the new cubic. 1, -2, -15, 36. Bring down the 1. 3 times 1 is 3. That's 1. 3 times 1 is 3. -15 plus 3 is -12. 3 times -12 is -36. And yep, we get another remainder of 0. Okay. All right, so now I've got a quadratic. I can bring this up here. Now I've got my quadratic. X squared plus x minus 12 equals 0. X squared plus x minus 12. This is easily factorable. What are the factors of 12 that add to 1? -12 that add to 1, that's going to be -4. That's going to be positive 4, negative 3. So x plus 4, x minus 3 equals 0. Flip the signs, and I get negative 4 and 3. Okay, so I've got a negative 4. That only shows up once. I've got a 2. That shows up once, but I've got a 3 that shows up 2 times. So the 3 has a multiplicity of 2. Add up your multiplicities, 1, 2, 3, 4, and that equals my quartic raised to the 4th power. Okay, so now, before I graph this, guys, if I look at my graph, I've got to, before I get a sketch and do the domain and range and all that stuff, I've got to figure out where are these little relative max and mins and absolute max and mins. If it is even, okay, it's either going to be an M or a W. All right, so it's either going to look like this or it's going to look like this. Okay, if you have an M or a W, for a W, you will always have an absolute min. For an M, you will always have an absolute max. And then you'll have these other relative mins and maxes. Okay, all right, so this is even, and there's no negative in front. Okay, so this is going to be our W. Okay, so I need to find this absolute minimum way down here off the screen that I can't see, and I need to find these 2 spots right here. Okay, so I'm going to use Mr. Spidey. Okay, second calc. Let's go find the relative minimum, maximum first. Okay, so I want to find this little relative max spot. All right, so Mr. Spidey is sitting at 0, negative 72. He's way down here, so I need to move him to the right. And I'm keeping an eye on my x-coordinate. I should start to see him pretty soon. There he is. Okay, I just need Mr. Spidey somewhere to the left. My calculator needs a left bound. I'm going to bracket the spot that I'm trying to find. So I just need it to the left. That's good. Press enter. Now my calculator says, okay, Mr. Manise, I need a right bound. So I'm going to move it. Got to be careful here. I'm going to move it just to the right. That's good. Either one of those spots are good. Press enter. Yes, I want you to guess. Press enter a 3rd time. There's my relative maximum. I'm just going to round to the nearest tenth. 2.3 and 2.3 comma 0.9. Okay. All right, so for my relative max and min, I've got a relative max sitting at our, this is a coordinate point, 2.3 comma 0.9. Okay. All right, now let's go find our next guy. Let's find this little relative minimum. Okay, our relative minimum, it certainly looks like it's our x-intercept. It looks like our 0. Let's just confirm that real quick. Minimum. Okay, I need to move Mr. Spidey to the left of the minimum. I can't be over here, guys. If I do this, my calculator is going to blow up because I'm on the left side of a maximum. Okay, so I actually need to move it just to the left of this minimum. Okay, this is no good. Let's go right about there. Should be good. Enter. Move it to the right. Anywhere to the right is fine. I can go off the screen if I want. Yes, I want you to guess. Press enter a 3rd time. And there is our relative. And as you can see, this is just a glitch in the Texas Instrument software. This is 3 comma 0, which is our 0. Okay, our x-intercept. So our relative minimum is going to be 3 comma 0. Okay. Now, what about the absolute minimum? I can't see it. That's fine. Second calc, I'm still going to use Mr. Spidey to find the minimum. I need it to be on the left, so I need Mr. Spidey to be on this little piece over here. So I'm going to move Mr. Spidey to the left. Now, I'm not going to see Mr. Spidey until I get to an x-coordinate of about negative 4. So I'm just going to keep on typing until I get close to negative 4. And I should start to see him right about oh, can I not see him? Huh. That's interesting. I think that's the first time I've ever seen that. I actually can't see Mr. Spidey anywhere on the screen. But it doesn't matter, right? Because if I'm over here on this piece, I know I will be to the left of this absolute minimum all the way down at the bottom. I just need to be to the left. If I'm at negative 4, heck, I can go all the way to negative. I can go to negative 100 if I want. I'm to the left of it. Okay, so press enter. Now I need to move Mr. Spidey to the right. I'm just going to move Mr. Spidey until I see him over here. Okay, so let's hold it down. All right, there's Mr. Spidey. He's definitely to the right of my absolute minimum down here. Press enter. Yes, I want you to guess. and there is my absolute minimum. Okay, it's way down there, right? Negative 2.3, negative 205.4. Okay, so I have an absolute minimum at negative 2.3, comma negative 205.4. Okay. All right, so now I'm ready. Now that I have my mins and maxes and my zeros, now I'm ready to sketch a graph. So let's plot these points. Let's plot our zeros first. I've got a 0 at negative 4, 1, 2, 3, 4. I've got a 0 at 2, 1, 2. And I've got a 0 at 3. Okay, I need to plot these points. My relative max is at 2.3, comma 0.9. So 1, 2, and a little bit more, and almost up to 1. That's going to be about right there. And then my relative minimum, of course, is just the 0. And I've got this absolute min down here. All right, this is going to be a W. Okay, so I'm coming in from the top. All right, so I'm coming in from here. I'm going to go all the way down to negative 2.3, comma negative 205. So about, there's negative 2, so somewhere way down there. I'm going to go way down here, all the way off, and I'm going to hit some rock bottom. I'm going to hit that value, which is negative 2.3, comma negative 205.4. And then I'm going to start to come back up. Okay. The multiplicities for the 4 and the 2 are 1. Okay, so that means I'm going straight through them. So I'm going straight through that guy. I'm going straight through this guy. I'm going to turn over. And now when I come back down to the root of 3, what's going to happen? It's a multiplicity of 2, so I'm going to bounce off of that guy. Okay, now I know that looks like a wacky W, but it still is a W. Okay, so there's my graph. All right, my end behavior. Okay, end behavior. This is, I don't expect you guys to write this down, but this is kind of the way we learned it in the lesson. It's even and it's positive, so that's going to be up, up. Okay, and as you can see, both of the endpoints are both pointing up. But technically, the end behavior is going to be as x approaches infinity. Okay, as my x values go this way, what are happening to my y's? My y's are going up, so the y's are approaching infinity. Okay, as x goes to negative infinity, guess where my y's are going? They're still going up. That's why we say up, up. So both of my y's are headed towards up, infinity. Okay, my domain for every single polynomial on planet Earth, the domain is always negative infinity to infinity. It doesn't matter whether it's an S, odd, even, W, M, it doesn't matter. Okay, all of these guys, it doesn't matter. I will always have X values everywhere. Okay. All right, my range. Now the range is where it gets a little tricky. Range, I only care about the Y values. Okay, so Karate Kid, right? Paint the fence. I'm sweeping from bottom to top. If I'm down here, I don't have any Y values. This is a void. This is the abyss. There's nothing down here. I don't have any Y values until I sweep up, until I hit the Y coordinate of my absolute minimum. Okay, that's a Y value of negative 205. And I do put brackets on it technically. Okay, so my range is that negative 205.4 number, and then as I sweep up, I will continue to have Y values everywhere until I hit what? Until I hit infinity. Okay, I can't touch infinity, so I'll leave that as a parentheses, but I do include this point. That's why there's technically a bracket right there. Okay, is that everything? I believe that is everything. All right, so hope you guys enjoyed this video. Wish you guys the best of luck on your test, and we will see you on the next one.